Hello class, I would like to look at the second part of the review for upcoming exam 31. Alright, so for this question, in fact, you can refer to number 95 from our PQT. It's the video that I previously made regarding properties of logarithm and log equations. Alright, number 11, similarly to the earlier one, you can refer to number 92 from our PQT. Then you should be able to find the solution also there. All right, number 12, likewise, but from number 94. They'll be the same question as this one. Let's get started with number 13. Now, in this case, what we can do is we can try to express that using the calculator here. So first, what we can do is we can put down the log base. So that means math and go up. And base was equal to 2. And here we end up getting x. And then if you have to graph it, then we're going to get the graph that looks something like this. Then what does this graph look like the most? In fact, yes, this one is similar to choice number 1, and that becomes our answer. Number 14. So let's look at it. 81 to this expression and 27 to this expression. How are we going to find out the values of x? So one way which we can do is by looking at the common base. See, 81 can be expressed as 3 to the 4th power, while 27 can be expressed as 3 to the 3rd power. So by substituting 3 to the 4th and 3 to the 3rd in two corresponding places, here we end up getting 3 to the 4th power to x cubed plus 2x squared is equal to 3 to the 3rd power to the 5x over 3. Now, then as we distribute 4 and 3, then we end up getting 3 to the 4x cubed plus 8x squared is equal to 3 cancels out with the bottom 3, which ends up being 3 to the 5x power. Then in this case, we realize that the two exponents must be also be equal to each other. Then what we end up getting is 4x cubed plus 8x squared must be equal to 5x. Now, if you have to subtract 5x from both sides, then we end up getting 4x cubed plus 8x squared minus 5x is equal to 0. Of course, the first thing which we can do is we can factor out x. Then we have 4x squared plus 8x and minus 5 has to be equal to 0. Now, when you want to try to factor this one, either you can do the factoring, or if you cannot think of the factoring, then you can always use the quadratic formula. But in fact, this can be factored quite nicely with 4x and x to get in fact 4x and x, instead of 4x and x will be in fact 2x and 2x, and one of the 2x is with positive 5 and the other one is negative 1, hence we end up getting negative 5 is equal to 0. Then here we end up getting x has to be equal to 0 from here, and 2x minus 1 is equal to 0, which will get us x must be equal to 1/2, and here x becomes negative 5 over 2. So we have 3 answers. In fact, what we needed to do is we should check if each one of them works, but in fact when you plug them in, you will realize that all 3 of them will work. So for example, check. We will just do one of them. How about 1/2? Then here what we end up getting is, you can use your calculator to do it also. You can store 1/2 as an example. Store it here as a alpha a. Then in place of x's, I'm going to put a. Then we should be able to get the expressions correctly. So we have 81 to the alpha a to the third power, and then plus 2a squared. Now, that's equal to this value. Alright, so let's see what we end up getting with the other one. 27 to the 5 times a, which is 5a, and divide by 3. And we end up getting same value. So we realize that the value that we have plugged in for a was correct. And likewise, we can do the same thing with negative 5 over 2 and also with 0. Alright, let's look at number 15. Here, how are we going to find out the value of x? What we can do is we can simply turn this one into exponential form. Then we end up getting 4 is the base with the exponent of 3 is equal to x. Then this is rather simple. What is 4 to the third power? That's in fact equal to 64. So therefore, our answer is choice 3. Number 16. Similarly, here what we can do is x plus 1 to the third power is equal to 27. In other words, what we have done was we turned the logarithmic equation into the exponential equation. Or rather, we can say power equations, because our variable is on the base. Now, to get rid of 3, what we can do is we can get the reciprocal of 3, which is 1/3, to both places. Then here, these two cancels out. We have x plus 1 equal to 27 to the 1/3 power, in fact, is equal to 3. Then subtracting 1, then x being equals to 2. That's what we end up getting. Number 17. The relationship between the relative size of the earthquake, S, and then the measure of the earthquake on the Richter scale, R, is given by in this manner. So, I mean, even if you don't know the science behind it, what's important is this equation for us. If the earthquake measured 3.2 on the Richter scale, that means R is equal to 3.2. What was its relative size to the nearest 100? So, in other words, we are looking for log of S equals to 3.2. And we like to figure out the value of S. Now, in this case, since we don't see any base, we can assume that it's a common logarithm. In other words, log base 10 of S is equal to 3.2. Then to figure this one out, we can convert this one into the exponential form. We end up getting 10 to the 3.2 power is equal to S. To calculate that, we end up getting 10 to the 3.2 power. That's what we end up getting. In other words, our answer should be 1584. Now, to the nearest hundredth, that means 0.89. So that becomes our answer. Alright, so let's look at the next question. Number 18. Here, to find the value of x, we're going to do something very similar, which is turning this one into exponential equation. Then we end up getting 8 to the 2/3 power is equal to x. Now, simply what we can do is put this one into our calculator. Then we end up getting 8 to the 2/3 power. Then we end up getting 4. Therefore, 4 becomes our answer. Number 19. So now, before we just turn this one into the exponential form, what we have to realize is that how can we combine the logarithms into one logarithm? Since we see the addition, that implies the multiplication. So we end up getting log base 3 of x plus 4 times x minus 2 is equal to 3. So if you have to convert this one now into the exponential form, then we end up getting 3 to the 3rd power is equal to, here we get x squared minus 2x, and then plus 4x becomes plus 2x, and then minus 8. Now, since this one is equal to 27, as you subtract 27 from both sides, then we end up getting 0 equals x squared plus 2x minus 35. In fact, this can be factorable as in x plus 7 and x minus 5. Then x then will be equal to negative 7 or 5. But one thing is negative 7 cannot be the answer, not because it was negative. It makes the values inside of the logarithm to be negative. And that logarithm is only defined on the positive values. So therefore, 7 has to be rejected. Only accepted answer is 5. Number 20. Similar to the last question, but in this case, since we have two logarithms are subtracting from one another, we end up getting division. So we end up getting log base b of 36 divided by 2 is equal to log of x, or log b of x. And we realize that this one is equal to 18, so this 18 has to be equal to the value of x. So x equals 18. And that becomes our final answer. All right, thank you, and I'll see you later. Bye-bye.